To psychology students, I want to make a quick review of neurotransmission for the assessment. I wish I still had a stylus, but I don't have one anymore. So I think there's a couple multiple choice questions. I think I made the test. There's a couple multiple choice questions. These are the terms. You need to know what a neuron is, neurotransmitters, and then the parts of the neuron. The neuron is the entire cell. Many cells together create nerves. And then the soma, dendrite, axon, action potential, synapse/synaptic gap. We kind of use them interchangeably, though they're technically different parts. And then reuptake, which happens after neurotransmission. Got that for your reference if you want to represent the cell body. But the big thing you need to do is you need to be able to explain the process. So I would say always start with the soma of the neuron. That's the cell body right here, and that's what's going to create the connection. So here's what we're going to do. OCD has been linked with low levels of the neurotransmitter serotonin. So what we're going to say is we'll start with the soma of one neuron. So the soma, we'll start off. The soma sends a signal to release serotonin. Okay, that's going to be the cell body that's going to be sending that. And then we got to think about where does it go next. Well, if we travel down here, I would say that start with the soma. The next thing is going to be the axon. The axon acts on the other neurons by creating action potential. So you got those A's there, axon. So the axon receives, and think about those paper clips too. Remember that game we played? That was the idea, was to give a physical creation. Think about it, I guess. Axon receives the signal and creates action potential in the terminal buttons. Terminal buttons was not a term, but it's one that you're probably going to want to know. All right, terminal buttons. Okay, so what did we use? We used action potential, we used axon, we used soma. So now we got to use synapse and reuptake. So serotonin is released from the synapse across the synaptic gap. Okay. I'm going to use dendrite, same one, and binds with the dendrite of the next neuron. So the last thing that's going to happen is the dendrites like Latin for like little trees. And if you look at these, they kind of look like little trees coming out, little fingers coming out, and they're very, very close, but there's still a little bit of distance in that synaptic gap. And they bind kind of like a lock and key mechanism. And then some neurons bind, some are reabsorbed via reuptake, and some dissolve or dissipate in the synaptic gap. So those are the four big steps. You've got soma. I usually put axon and action potential together. You can make them separate ones if you want to. And then I also have synapse/synaptic gap and dendrite in the same one. You can make them separate. You could even move the dendrite down here and then talk about reuptake. So those are the big steps right there that we need to know. And it just follows along the neuron right there. What point or step in neurotransmission is most likely to cause low levels of serotonin? So there's a couple ones you could think of. The first is that during the action potential phase, you could have a leak out of the axon of the neurotransmitter because of the myelin sheath not being strong. However, if that's the case, you're going to have more going on than just OCD probably. You're going to probably have issues of multiple sclerosis or other issues of just a breakdown in your neural cells. So where it's probably going to happen is we think about, why does reuptake happen? Well, reuptake happens because there's not every neurotransmitter can bind. So the issue of low serotonin levels is probably because not enough serotonin is binding to those receptors to create further neurotransmission. Remember, it's an all or nothing process. If not enough serotonin or any neurotransmitter binds to the next dendrite, then the next neuron will not send another signal to release serotonin. So you're just not having enough. So this is going to be across the synapse or the synaptic gap, binding to the next dendrite. So basically what's going to happen here is the signal breaks down and no further serotonin is released. If you remember, I talked about how the number one prescribed psychoactive drug in America is SSRIs, or selective serotonin reuptake inhibitors. And what those do is they block the process of reuptake, because theoretically, if more serotonin is just sitting in the synaptic gap, the more likely it is to actually bind to the next neuron. And that's because this is where it breaks down. So now you know. All right, quick review. Hopefully that's helpful. And the slides are on Teams if you want to check those out as well. Please subscribe to my YouTube channel. Smash that like button. Make sure we keep those likes higher, those dislikes. All right, I'm out.